In this tutorial, we'll solve question number 4, paper 41, November 2024. A bus travels between two stops, A and B. The bus starts from rest at A and accelerates at constant rate of A until it reaches speed 16 meters per second. It then travels in this constant speed before decelerating at constant rate 0.75 A, coming to rest at B. The total time for the journey is 240. Sketch the velocity time graph. This is the normal one. Start from rest, accelerate. This is the first part. Then move with constant velocity like this. Then decelerate like this. Starting from rest, reach to velocity 16. This duration time is not given. This deceleration time is T2, and this time is T. The acceleration for this part is A. As we know, this is A, which is equal V minus U over T. But this acceleration is 0.75 A, also which is equal to V minus U over T. He asked to sketch the velocity time graph for taking the time is 240. This is part A. Find an expression in terms of A for the length of time that the bus is traveling with constant speed. For the first part, you can find the time acceleration. It's A is the final velocity is 16 minus the initial velocity is 0. The duration time is T1. By using cross multiplication, you can find T1 is 16 over A. By the same way for the second time, acceleration is 0.75 A is equal to V minus U over T. It's better to write here, if you write here negative, because it's a deceleration, and the final velocity, you have to write 0 minus the initial, which is 16 divided by T2. Negative and the negative we can cancel, so the acceleration is equal to 16 divided by 0.75 T2. You can simplify it and write 16 divided by 0.75, 16 divided by 0.75 to write it as a fraction in its simplest form. So the acceleration is equal to 64 divided by 3 T2. So when you get T2 as a subject, T2 is equal to, by using a cross multiplication, will be 64 divided by 3A. So the length of time, T, is equal the total time, which is 240 minus T1 and T2. 16 over A and 64 divided by 3A. There is no specific form he asked to write, so leave it as it is. Part C, given that the distance from A and B is 3,000 meters, find the value of A. The distance represents the area under the graph and the x-axis. So you can find the area of trapezium. The area of trapezium is 3000 is equal half. Area of trapezium is equal to half height A plus B, whereas A and B have to be parallel. So have the height, the perpendicular in between, which represent the speed, which is 16 bracket, A and B, which is 240 and T and 240. From this equation, we can simplify and solve to get T. How? Half of 16 is 8. So 3000 divided by 8 is equal 375 is equal T plus 240. By finding T, so T equals 135. If we back again to the question part B, T is equal 135. So from this equation, you can calculate value of A. T is 135. Remove T and write 135 is equal 240 minus 16 over A plus 64 over 3A. By moving negative to the other side, will be 16 over A plus 64 over 3A. You can find it as a single fraction. It's equal to 240 minus 135. By writing this part as a single fraction, the denominator will be 3A. So this will be 48 plus 64 is equal to 240 minus 135. The answer will be 105. Simplify more. 48 plus 64, which is equal 112, divided by 3A is equal 105. Use cross multiplication. So 3A multiplied by 105 is equal 112. So find A subject, which is equal to 112 divided by 3 times 105. Write your answer in its simplest form will be 16 divided by 45. This is the final answer he asked to find the exception. Thank you.